there is increment after pH 7 to 10 of the protease activity. Meanwhile, after 10 pH 10, protease activity will be dropped. Okay, we can after this I will give information about this protease activity towards pH. Okay. Okay, that at the same time here, we are focusing on the effect of inhibitor on protease activity. So various inhibitor we try to use, including elastatin, PMSF, pepstatin, EDTA, and so on. Because different of inhibitor represent different types of classification of the enzyme. So we can see here PMSF able to inhibit a protease, meaning that this protease belong to serine protease because only PMSF able to inhibit serine protease. If EDTA inhibit the protease, that protease is belong to the metalloprotease. Okay, similar like pepstatin, the protease will be inhibited by pepstatin due to this, because of this protease is belong to aspartic protease. Okay, we move to the temperature stability and thermostability of the protease. Okay, we can see figure here the effect of the temperature on protease activity. The enzyme able to work well at high temperature up to 80 degrees Celsius. And then we try to study the thermostability, shows that at 70 degrees Celsius, the half-life of the enzyme is around 7 hours. For the 80 degrees Celsius is around half-life is around 4 hours, meaning that this enzyme protease able to withstand at 80 degrees Celsius for 4 hours, but not for the 90 degrees Celsius. The enzyme activity drastically drop. Okay, but today I didn't focus on the thermostable, but this shows that my enzyme serine protease 50A, which can be categorized under thermostable enzyme. Okay, we move the main point of the enzyme, which is construction of the structure of protease enzyme. I call it STAP50A. Okay. I have a sequence, which is primary sequence, that we can use that primary sequence to predict the structure. Okay. Maybe many researchers focus on the produce crystal structure, and they're able to produce also produce 3D structure by using experimental study. This is using in silico study. By using primary sequence, we can predict 3D structure based on the template that available in protein data bank. Normally, protein that submitted or structure that submitted to the PDB, protein data bank, normally is come from crystallography structure. Okay, so why we have to come up with the 3D structure? Normally we can use in order to study the function of the protein, okay, or enzyme. Or other researchers can study on the drug design. Okay, this is level of protein organization. Okay, start from the nucleotide, reduce to the amino acid as a primary structure. Then we can predict the secondary structure based on the primary structure. So that secondary structure, there is alpha, beta, alpha, helix, and beta strand. Then from that structure, secondary structure, we can predict the stationary tertiary structure, which is folded protein, which this protein able to functional well, and we can study how they work. At the same time, maybe we can focus to a quaternary structure when the protein has a few subunits to form a group of the quaternary structure, like hemogroup, like hemoglobin structure. Yeah. Okay. The application of the 3D structure, for example, here I can study about mechanism of action of the protease. Okay, as I'm show here, the structure of the trypsin, chymotrypsin, and elastase. Okay, each enzyme here has different types of pocket, binding pocket. Like trypsin, they have deeper and deeper binding site. But for the chymotrypsin, this chymotrypsin has broad specific binding site. Meanwhile, the elastase very short and a little bit of the binding site. So we can know which amino acid can fit to the binding pocket at active site. So we can know what kind of amino acid can be hydrolyzed by this enzyme. Okay, the next page figure is about drug design. In order to come out the new drug, for example, new drug for the certain application. Okay, how to do, Dr. Wee, sorry, I have how many minutes?
Dr. Azlina, you still have 10 minutes.
Okay. Okay, this is a step to do homology modeling. Let's skip this one. Okay, and this is, I use available software and tools that available in the website, which is free, in order to come up with the 3D structure. So I use cluster W blast to align the sequence. I use Swiss model for the homology modeling, and but we can use modeler. We can use modeler also to predict 3D structure.
Dr. Azlina, sorry for interruption. You still have 5 minutes.
5 minutes. Okay, it's okay. And then from this primary sequence, I can predict the structure. But before that, I have to remove signal protein, propeptide from the sequence, and then just take the mature protein to do prediction. Okay, why we have to remove? Why this signal peptide and propeptide ni attached to the mature protein? Because this pre-protein act as a postal code, which is try to direct the protein expression. Okay, from the sequence, I try to find the best template for the 3D structure. This is available. Server or website can be used, and they propose the best structure as a template for predict 3D structure of the AP58. Okay, this is sequence alignment between one MME, one MEE, which is proteins belong to the Bacillus tumulus, and then the identical or identity of these two enzymes is around 93 sequence. Okay, then Swiss model predict the structure to me. This is the structure, and this is the next figure is focus on the what we call it active site. Here there is 3 amino acid representative catalytic triad contains of aspartic acid, histidine, and serine. Okay, then this structure must be evaluated in order to know whether this structure are correctly predict or not. There are 3 software or server can be used to predict this the structure, like Ramachandra plot, okay, verify 3D and ERA. Okay, so this evaluator propose mention that the structure is significant, correct without refinement. Okay, but maybe for the other purpose, for the simulation, but the structure must be refined first. Then we can do simulation. Okay. Okay, the last one is about possible mechanism ataupun reaction mechanism of the enzyme based on the alkaline condition. Okay, this is we are focused on the catalytic ataupun binding pocket. The main amino acid here is serine. Serine amino acid, which is at what we call it accept the OH because of when we put a protein inside the alkaline condition, OH more what we call it more than when we put the other pH condition. Okay, this is a mechanism of action. The proton abstraction happen to the serine, then the aquaphilic attack, rearrangement of the structure, then they able to produce product by nucleophilic attack. Then formation, there are 2 formation ataupun there are 2 product formation in one cycle of the mechanism ataupun catalytic activity, P1 and P2. P1 is the first formation from which is produced amide product. Meanwhile, P2 formation is produced based on the carboxylate product. Okay. Oh, sorry. The last one. Why this enzyme able to work well in around 8 to 10, and then why this enzyme unable to at all drastically drop activity after pH 1. I just would like to focus on why drastically drop at pH 1 because of OH ion maybe overprotonate. Kenapa tak bergerak sini? Okay. Overprotonate the critical residue like serine and disrupt the active site geometry. At the same time, OH from the alkaline condition able to destabilize the enzyme tertiary structure and leading to the denaturation of the enzyme. And lastly, maybe the OH disrupt the hydrogen bond in the oxyanion hole, which is at the binding pocket, and reduce stabilization of the transition state. Okay. Okay, that's all from me. just would like to conclude that we are able to predict 3D structure and try to study the mechanism of action of the proteins and why it can we can it can it can it's able to active at high pH. That's all from me. Thank you.
Okay,
Pass
thank
to
you.
Dr. B.
Thank you so much, Dr. Azlina, for the very insightful presentation. Due to time limitation, Dr. Azlina, we cannot take any question. I will show you have any question to ask Dr. Azlina, feel free to contact her directly. Okay, Dr. Azlina will be very happy to answer your question. Okay, Dr. Azlina. Okay, next we have our next invited speaker, Professor Dr. Ong Kiet Kin. Dr. Ong, are you here? Professor Ong?
Yeah. Yes.
Okay. Okay, let me give some introduction about Professor Dr. Ong Kiet Kin first. Okay, Professor Dr. Ong Kiet Kin received her PhD from UC Putra Malaysia, UPM, in 2007 and joined as a senior lecturer at National Defence University of Malaysia, UPNM, in 2008. From 2010 to 2012, she served as head of chemistry department, and currently she is a professor and senior researcher actively supervising postgraduate and postdoctoral researchers. Her research focuses on analytical and environmental chemistry, particularly in developing novel detection methods for hazardous compounds and applying green chemistry to reduce carbon dioxide and heavy metals. She has led numerous research projects funded by Ministry of Higher Education and UPNM. Her innovation include control release fertilizer using biopolymer materials and portable device for on-site arsenic and pesticide detection. She has published about 100 papers in peer-reviewed journals and conference proceedings. She holds 5 patents and 2 copyrights. Her work has been recognized with multiple gold medals at international exhibitions, including International Innovation and Technology Exhibition, ITEC 2011, the Seoul International Invention Fair 2015, and International Trade Fair for Ideas, Invention, and New Product, IENA 2016. She is also 2-time recipient of Excellent Service Award and 2010 and 2015 and has presented her research at various international conferences. Okay, Prof. Ong, you have 30 minutes for this presentation. Okay, so the floor is yours.
Yeah. Okay, I just want to share the slide. Window.
Okay, Prof. Ong.
Yeah.
The upper right-hand side, you can see share button.
Yeah. I already clicked share. Now I'm looking for my slide.
Okay, never mind. Take your time. Don't worry.
Sorry, I do not. Wait. Sorry. I take.
Don't worry, Dr. Prof. Ong.
Yeah, please hold on. Okay. Window. The screen. Okay, let's get slide update to share. Okay, window right. See, I cannot. I don't know how to share the slide. Okay, just now.
Prof. Ong, you just go to the share button.
Yeah, I already click share, but can you see the slide?
You can choose the share window.
Yeah, I choose already. Share window. Wait. Okay.
But also we have a new university launcher. So we can go to the 30nm resolution. You can get the face or get the green side, get the visual orientation or the visualization for examples. Also, we will provide the talent.
Okay, Prof. Ong, you can
just want to confirm
share
that,
the
is it?
screen or also share the window.
Am I in the correct room or not?
Yeah, you are in the correct room. Yeah.
Correct, huh?
Yes, yes.
Because I heard somebody sound voice.
Yeah, we're gonna turn it off. Don't worry.
Yeah, because I heard somebody talking. I don't know. I'm confusing.
Yeah, that's from the room, the other room.
Oh, now can you see my slide?
Not yet.
Huh?
No, we can not see.
Can you see?
Okay, now, yeah, now we can see it. Okay.
But I just wondering where I hear somebody speaking. So how is it?
No worry.
What should I do? Because I see.
Okay, Dr. Wong, Dr. Ong. Okay, you're good now. You're good. You can start now.
Can start now.
Yeah.
Because I hear somebody voice.
Yeah, we're gonna solve that technical problem. Don't worry.
Then I just carry on. Is it correct?
Yeah, go ahead.
Okay. Wait now. Wait 1 minute. 1 second. Okay. Just you can see my slide. Then okay lah. I go on. I just wondering why I can hear somebody else. Okay, fine. Never mind. Sorry.
Okay.
Good morning. Thank you, Chairperson. Okay. I'm Prof. Ong from National Defence University of Malaysia. Okay. Okay. I would like. Can I just? I want to. Wait lah. I just want to off the speaker first lah because I hear somebody talking. I cannot. Okay. So
Okay. Don't worry.
now can you hear me?
Yes, we can hear you clearly.
Sorry. Can you hear me?
Different surfaces. So that's about.
Okay. Pro Ong, I guess you open the other room as
so
well.
How do I do? I go out.
You need to sign out the main room.
Okay. So
Okay,
how about now?
Now okay. Now okay.
Now
Clear.
okay, huh? Because
Yes.
just now maybe I accidentally joined the other room.
Yes, you're right.
Okay, now I start again. Sorry.
Okay. Good.
Sorry. Okay. Okay. Good morning. Thanks to Chairperson. Okay. This morning I would like to share with you about a simple paper-based colorimetric assay for detection of malathion. So this is part of my PhD student, Madiato Iftia Arifin. She's currently writing her thesis. Okay. As we know, chemical pesticide can increase agricultural food crop yield, but excessive and uncontrolled use of pesticide will cause food contamination, as well as environmental, aquatic, and agricultural pollution.
Prof. Ong,
Huh?
can you make your slide to presentation mode?
Oh, okay. Okay, let me. Okay. You cannot see my slide.
We can see your slide, but not in the presentation mode.
I slide show already. So what should I do? Because I already done slides. Oh, is it correct? Now, how about now?
Now, okay, but still not in the presentation mode. But it's okay. You can just make it bigger. I think it's okay if you can read it.
Because I
Feel free.
do the
Yeah, you can
slideshow,
proceed. Don't worry. You can proceed.
Proceed lah. Sorry. Because I
Okay.
already done the slideshow.
Okay, no worry.
Okay, I start again from this slide lah. Okay, as we know, chemical pesticide can increase agricultural food crop yield, but excessive and uncontrolled use of pesticide will cause food contamination, as well as environmental, aquatic, and agricultural pollution. Malathion is an organophosphate pesticide that commonly used in agricultural sector. Okay, these figures show the classification of pesticide according to their use. For example, pesticide can be classified into insecticide, fungicide, nematicide, and so on. Okay. Meanwhile, this shows the effect of pesticide in the environment. Okay. Organophosphate pesticide are actually toxic because they can poison our nervous system. Under normal condition, our nerve cell will release neurotransmitter acetylcholine, and transmit the impulse to our muscle or organ. And then acetylcholine esterase will immediately break down the acetylcholine to allow our muscle or organ to relax. As shown in this chemical equation, acetylcholine will broken down to acetic acid and choline with the acetylcholine esterase enzyme. Okay, but in the presence of OP, the OP will form covalent bond with active site of acetylcholine esterase, where acetylcholine would normally be broken down by hydrolysis process. So acetylcholine will increase, then impulse are continuously transmitted. So our muscle contraction will continue, which cause harmful effect to our body. One of the conventional instrument can be used to detect pesticide is in the lab is GCMS. Okay, but although this GCMS is sensitive, accurate, and reliable, but you can see this picture. The GCMS is.
Prof, I'm sorry for interruption again.
Yeah.
You seem like your slide is not moving. Okay, now it's moving.
Now moving.
Okay. Maybe you can choose to reading mode.
How to choose a reading mode?
Next to the presentation mode, the next one at the center.
That means I have to go back to see the Microsoft Team, is it? From them?
No, okay. So can you see the icon down there? At the bottom.
Okay, let me wait lah. Icon where?
Okay.
Good. That means I go back to Microsoft Team, right?
No, at your just go to
my slide.
Your slide,
okay.
And then at the bottom,
yeah,
this is an icon next to the presentation mode. There's a reading mode. Maybe you can do from there.
I don't know which one is the reading mode. Sorry.
You can see the one that with the books that is opening, just next to the presentation mode.
Oh, okay. Let me check. Let's see. Let me try. Look like a book. What you mean?
Yeah.
This one.
Okay. Now it's good. Now it's good.
So okay, this one lah. So I try to.
Sorry for interruption.
The slide is moving. Okay, right?
Yeah. You're right.
Sorry. Sorry. Normally I do the slide. So okay now.
Okay.
Okay, I just continue this again. Okay. Sorry. Okay. One of the conventional instruments used for pesticide detection is GCMS. So as you can see in this picture, the GCMS is bulky, sensitive, and time-consuming, and which require technician to run the instrument, although it is sensitive, accurate, and reliable. So this GCMS is not suitable to be used in the field for detection of pesticide. So we have to come up a simple, rapid, and portable detection approach, which is a sensor or test kit to detect the pesticide in the field. Okay, calorimetric is one of the extensive method used to develop sensor. Okay, the calorimetric method detection is based on color chain, as you can see in this figure. Okay, after we add the sensing reagent to the analyte, the color will change. When the concentration of analyte is higher, the colors become darker. Okay, we can interpret the result either using the naked eyes or the mobile apps or the software that we install in the software. Okay, so gold nanoparticles are widely used in developing a sensor because they are stable, cause distinct color chain, and produce the result in a short time. Okay, so after we adding the analyte, the gold nanoparticle will aggregate and then cause color chain from red to blue. Okay, and also cause the red shift. That means the lambda max in the UV spectrum will shift to the longer wavelength. Okay, aptamer-based sensor. Okay, what is aptamer? Aptamer is a single-strand DNA or RNA molecule. It can bind to target molecule or analyte with high specificity or high affinity. Aptamer sensor is a biosensor where we use the recognition element is DNA or RNA aptamer. Aptamer can conjugate with gold nanoparticle and also widely used. Okay, aptamer can interact with the analyte, form the aptamer-analyte interaction. So the gold nanoparticle will aggregate and color change from red to blue. So these figures show that aptamer, after they folding to the 3D structure, they will form the stable aptamer complex. So which can, for example, the protein is one of the analyte. Okay. Okay, this slide show how colorimetric paper-based sensor has been used to develop to detect pesticide. Either they're using a gold nanoparticle or silver nanoparticle. All this is about a paper-based. Okay. And then if we want to increase the accuracy of the colorimetric sensor, we can integrate the colorimetric sensor with image analysis process. But how? Okay, after we capture the image of the solution, the solution which contain the analyte and the sensing reagent, we can process the image and analysis the image. We can use software, for example, ImageJ, and then this is the free image. This is the free software. Then from the image, we convert the digital signal. That means got value. Okay, this digital signal can be, for example, red, green, blue value is in value form. Okay, so from there we can construct a calibration curve by plotting digital signal versus analyte concentration. As you see, this one is the calibration curve. So from this calibration curve, we can use to determine the analyte concentration in the sample. Okay, and this figure show a few examples of the colorimetric detection using image analysis process in order to detect the pesticide. Okay, there are two objectives in the study. The first one is to develop paper-based colorimetric ATAC sensor for malathion detection. And then the second one to evaluate the performance of the developed ATAC sensor. Okay, so now have a look on the method. At first, we have to synthesis citrate cap gold nanoparticle, and then followed by characterization of citrate cap gold nanoparticle. And then we do the detection of malathion, followed by image analysis of digital image that we capture. Okay, and then we develop calibration curve before we do the interference study, and finally we conduct the MLT detection in the real sample. Okay, so this slide show how we synthesis a citrate gold nanoparticle. The method is very simple. We add auric chloride into the conical flask and then stir at 1000 RPM, heat it until boil. After that, we add trisodium citrate solution into this auric chloride solution, and of course we have to continue stir and heat so until the color change to red. So after the color change to red, that means so that the formation of citrate gold nanoparticle. And then we have to cool down the solution to room temperature before we store at 4 degrees Celsius. Okay. After we synthesis, we have to characterize the citrate gold nanoparticle. We want to make sure whether the gold nanoparticle is formed or not. Okay, so we're using UV spectroscopy and also TEM analysis. So this slide shows how we do the fabrication of the ATAC sensor using the Walkman filter paper. At first, we cut the Walkman filter paper into a rectangular size of 0.5 centimeter times 3 centimeter. After that, we rinse the filter paper and dry at 50 Celsius for 40 minutes. And then after that, we soak in the ethanol for 1 hour, and then rinse again. And then we dry it at room temperature for 1.5 hours. Okay, after that, we put the filter paper into the solution which contains citrate gold nanoparticle and DNA aptamer for 1 hour. And then finally, we dry it for 10 minutes before we want to use for detection. Okay, so this slide shows how we do the detection. This is the filter paper that we have fabricated just now. Then we just drop the analyte on the filter paper at a sample zone. This sample zone we already label, and then put the filter paper in the image capturing box. This image capturing box we developed using 3D printer, and then we capture the image using a smartphone. After that, we transfer the image into our laptop. So we process the image using ImageJ. Okay. So the picture show how is the image capturing box. So it's very small. We can put on our palm. Okay. Okay. Now just have a look on image analysis using ImageJ software. Okay. At first you have to open the file. After that, we click edit in order to clear the area outside the image. That means we clear that undesirable area of the capture of the image that we capture lah. After that, we want to measure the RGB value. We click plug in, analyze, then followed by RGB measure. So after this step, we will get RGB value, and then we calculate the delta RGB, which is the response of the data sensor using this equation. Okay, where R0, G0, and B0 red, green, blue value for the blank, and R1, G1, B1 red, green, blue value after we add the analyte, which is malathion. Okay. So this slide shows how we develop the calibration curve. We have to prepare different concentration of MLT by dilution of MLT stock solution. After that, we conduct the detection and image analysis, as I mentioned to you just now. Okay, from there, we get the RGB value, and then we plot the delta RGB versus the MLT concentration in order to get the calibration curve. Okay, for interference study, we add a different other interference beside the MLT. So this is the interference. We add each of the interference to the MLT solution. So both of them final concentration was fixed to 1000 micromolar. After that, we drop on the filter paper that test sensor that we already prepared, and then perform the detection image analysis as I mentioned to you just now. Okay, so this is the slide showing how we conduct the MLT detection in the real sample. We collect two types of sample, tap water sample and lake water sample. After that, we centrifuge the sample using a centrifuge at 5000 RPM for 20 minutes. So in order to remove any suspended solid, and then we do the degassing using ultrasonicator. We degassing for 20 minutes, and then followed by detection using 0.47 micron membrane filter. After that, we spike the sample with MLT in order to get a final concentration of 1000 micromolar. And then finally, we have to do the detection. Okay. Now just have a look on result discussion. Okay. From this UV spectrum, you can see that, this is the image of the citrate gold nanoparticle that we have synthesized. So from this UV spectrum, you will notice that there is a characteristic surface plasma resonance peak at 521 nanometer. So we can show that the formation of gold nanoparticle. Okay. In fact, this lambda max is similar to the previous study that using the similar synthesis method. Okay. And the others previous study also reported that normally the citrate gold nanoparticle have the lambda max within 520 to 525 nanometer. So from this result, we can say that we have successfully synthesized the citrate gold nanoparticle. So in addition, we also conduct the TEM analysis. From this TEM image, you can see that the citrate gold nanoparticle have a spherical shape with average particle size of about 15.4 nanometer. Okay, this particle size also similar to previous report. So again, this TEM also can confirm the formation of gold nanoparticle. Okay, so this is also the MLT detection mechanism that I propose. Right, the detection is based on aggregation. Okay, so before detection, the gold nanoparticle is in dispersed form. After we add the analyte, you cause aggregation, the color will change from red to blue. Okay, this mechanism is supported by the TEM image. As you can see here, before detection is in this citrate gold nanoparticle in dispersed form. After adding the analyte, it become aggregation. Okay, actually the detail is mechanism is shown in this one. So where the first citrate gold nanoparticle bind to the thiolated DNA aptamer through the strong gold and sulfur bond. Okay, Without analyte, the atmer have the random conformation as a negative charge of atmer project outward. So there is no aggregation. When we add the analyte, the atmer will recognize and bind to the analyte. So will cause the conformation change from rigid random coil to rigid one. So this one will cause the aggregation of citrate gold nanoparticle. That's why the color will change from red to blue. Okay. Now have a look on the calibration curve. Under the optimal condition, we conduct the detection of different concentration MLT. From this calibration curve, we can see what is the linear range. Okay. So the calibration curve was constructed by plotting delta RGB versus the MLT concentration. And then the delta RGB can be described by using this equation where y equal to 0.0432x plus 14.05. Where y is the delta RGB, x is the concentration of malathion. And the response of delta RGB is highly correlated with the MLT because the R square is close to 1. Okay. From this calibration curve, you can see the linear range from 50 to 1000 micromolar with the LOD of 1.2 micromolar. The LOD was calculated using the equation that's described by Feng et al. Okay. From the interference study, we reported the MLT concentration response as 100%. So the other response after adding the other pesticide, you see it's also close to 100%. Okay, so we do the independent sample t-test analysis to confirm whether the response is it a significant difference with the MLT only. So from this p-value, you see that it's higher than 0.05, meaning that the response after adding other pesticide is not significant with the one with MLT only. So from this result, I can say that the aptamer sensor show the strong resistance to the interference and high specificity toward the MLT. Okay. This slide show the real sample analysis result. Okay, as I mentioned to you just now, we collect two types of water sample, take water and lake water, and then we spike the take water sample to get the final concentration of 1000 micromolar for each sample. And then this is the concentration that we detect using the sensor. So this result is close to the one that we add, close to 1000 micromolar. And the percentage recovery is good, is about 106%. And also the RST is low, which is less than 5%. So all these results showing that the test sensor show good accuracy for detecting the MLT in the real water sample. Okay, now I'd like to make conclusion. From the calibration curve, the response is highly correlated with MLT concentration with the linear range of detection from 50 to 1000 micromolar, the LOD of 1.2 micromolar. And from the interference study, there is no significant interference, so the test sensor is selective toward the MLT. And from real sample analysis, good percentage recovery, that means the good accuracy of the test sensor to detect the MLT in the real sample. Okay, now I would like to thank to Ministry of Higher Education Malaysia for providing the research grant, and also to National Defence University of Malaysia for providing the research facility. Okay. Okay, thanks for attention. And also thank to the organizer UMK for organizing such wonderful conference.
Okay, thank you so much, Prof. Ong.
Okay.
We can take one or two questions here.
I drink water first. Thirsty.
Yeah, sure, Prof. Okay, Prof.
Oh, yeah.
I have one question. Okay, I myself is a microbiologist. Okay, but I use colorimetric methods for detection for iron and also several different metals. And currently, my students are developing a method to use a colorimetric method to detect rare earth. But
To detect what,
unfortunately, rare earth
Rare earth. Oh.
rare earth elements.
Uh-huh.
Unfortunately, currently we don't have a consistent result.
Oh.
Sometimes we get it, sometimes we don't. Okay, do you have any how
Idea.
to say
How to solve the
tips
problem.
or ideas that what should we work on?
The concentration that you detect is how much is the concentration?
Okay, if we go to a very low concentration, like in micromolar, then we can get it. But if we try to go a bit
Nano.
higher, the result is not that reliable.
Oh, higher. I thought it's opposite. No, because I thought normally if you go lower, maybe a little, when you do a little bit error, so it's very difficult.
Yeah,
Because, okay, how you determine, because I convert the color image into digital value. Do you do that?
No, we just take the reading using a spectrophotometer.
Oh, UVVs, you mean UVVs?
Yes,
Take the
yes,
absorbent.
UVs, yeah.
Take the absorbent. Okay.
Mhm.
You mean your student didn't get the repeatable result? How?
We don't get the resistant result. So you mentioned that you use convert that image into something measurable.
Yes, correct. But you absorbent also same because it gives you the value, right? Otherwise, if you detect using naked eyes to interpret the result, so not accurate. So you use UVs, that means you give absorbent. So you say the main problem is because you say you prepare more concentrated, but it got problem. But you prepare lower concentration, it got better. You mean the result?
Yes. But never mind, Prof. Ong, since we have time limitation here, I will consult you later.
Okay, sorry.
Yeah, because
I try to think.
I really need help on this. Let's see if we have other question. Have other question? No. Okay. Since we don't have other question, okay. Prof. Ong, thank you so much. Of course, I will contact you later. Okay, because I really need help on this.
Yeah. I try to think to help. Okay, thanks.
Okay, thank you so much. Okay, so before we move to our next presenter, so I will request all the participants to kindly take a moment to register your attendance. Okay, you can click the link that we posted at the chat message for the attendance. Okay, next we have our next presenter. We have Miss Jewasri Anak Perempuan Ganesan, okay, with her presentation title, Stability and Physicochemical Properties of Evaluation of Watermelon Rain-Based Sunscreen. Miss Jewasri, are you here?
Yes, doctor.
Okay, Miss Jewasri, you have 15 minutes for the presentation. Probably 10 minutes for presentation and 5 minutes for Q&A. So the floor is yours.
Okay. Thank you, Dr. Lee. Can I start sharing my screen?
Yes. Prof. Ong, can you unshare your screen first? Okay.
Okay, already done. Sorry. Okay.
Okay, Miss Jewasri, you can share your slide now.
Okay. Can everyone view my screen? My slide
clearly. We can see
okay.
it clearly. Go ahead.
Okay, thank you. So I would like to thank Dr. Wee, first of all, and I will begin with my presentation. So good afternoon to distinguished speakers and guests. I am Jivashri Ganesan, currently postgraduate student from Faculty of Agro-Based Industry, and today I'll be presenting a part of my research on the stability and physicochemical properties evaluation of watermelon rain-based sunscreen. And to begin with the introduction, so as we all know that sustainability has become a growing focus in the cosmetic industry, and also consumers are more aware of their sunscreen products And one of the major concern in the use of cosmetic is the synthetic ingredient, which has been linked to the coral reef bleaching, hormonal disruption, and other environmental risk. So in response to this, there has been a shift towards using natural ingredients in cosmetic with a specific focus on agro-based utilization. And my study also focuses on utilizing watermelon rind, which is the white part of the watermelon, as a commonly discarded byproduct, which it has been discovered to be rich in bioactive compound like flavonoids, phenolics, and citrulline especially. These compounds have been discovered to have more antioxidant, anti-inflammatory, and photoprotective activity, making it convenient and a promising candidate for sustainable and effective sunscreen formulation. So based on the research gap, while watermelon rind has been widely applied in food and nutraceutical industry because it has high content and antioxidant, so it has been used like to promote shelf life and all that. So in cosmetic industry, it still been underexplored, especially in topical photoprotective developments like sunscreens. So for my objective of my study is to develop and evaluate the physicochemical stability of watermelon rind-based sunscreen and compare with the commercial sunscreen in market, and also to compare the physicochemical properties like color, pH, viscosity, spreadability, and greasiness among the watermelon rind-based sunscreen and commercial. And this study was to aim to contribute viability of watermelon rind as a functional, sustainable ingredient in cosmetic and contribute to waste utilization efforts from agriculture. So to begin with the materials and method, the sunscreen ingredient consists of two phase, which is oil-based and water-based. And for the emulsion, beeswax was used as the base ingredient and followed by other ingredients. And watermelon rind extract was pre-processed using ultrasonic extraction under 30 degrees Celsius for 70 minutes using ethanol as a solvent. And for the sunscreen development, technology like homogenizer was used for pre-emulsification for oil phase and also water phase. And the sunscreen after development was cooled until room temperature prior to next physicochemical studies. And based on the stability studies, two storage condition was evaluated on the room temperature with 27 degrees and chiller for 4 degrees Celsius. And as we assess the physicochemical parameters of both watermelon rind-based sunscreen and commercial sunscreen for 28 days, intervals of 0, 7, 14, 21, and 28 days, which is almost 1 month. And based on the parameters, color was observed visually because both of the sunscreen were basically in white color. So we didn't need any other devices. So it was just observed visually to see any microbial or any like phase separations. And pH was measured as general using pH meter, and viscosity as well using viscometer at 100 RPM. And for the spreadability, there was two spreadabilities. One is for speed using parallel plate method by using two slides, and depending on the weight to able to the first slide to slide off by the weight. And the second spreadability is by length, also by squeeze plate method depending on a weight between two glasses. And the speed is depending on the gravitational force and the consistency of the sunscreen. The other spreadability is to ensure the smoothness of the sunscreen. And lastly is for greasiness, using filter paper to measure the diameter of oil ring, which has been observed within 24 hours. And moving forward to the results and discussion, Both the watermelon rain-based sunscreen and commercial sunscreen maintain the consistent color throughout the stability period for 28 days. This shows that there was no degradation of active ingredients, indicating the stability of the formula. And this is a positive sign for the formulation. And it was suggested that the bioactive compound in watermelon rain extract remain intact. And the second was pH. For the commercial sunscreen, there was a minor increase in pH from 6.9 to 7, which is more to like alkaline base at day 14 under chilled condition. And for the watermelon rain sunscreen, the pH increased slightly from 6.9 to 7 on day 7, regardless of the storage condition in both room temperature and also a chiller condition. And it remained stable at 7 throughout the stability study. And this suggests that both sunscreen maintain a neutral pH, which is important for our skin compatibility and stability. And the presence of phenolic compounds in the watermelon rain extract may have been contributed to neutralize the pH of formula by its natural buffering capacity. And the third physicochemical is viscosity. And it is also another crucial parameter for sunscreen stability, as because most of the consumer, they prioritize the consistency of their sunscreen. And as we can see from the result, the commercial sunscreen has increased slightly over time at both room temperature and chiller. And similar to watermelon rain sunscreen, and there was a gradual increase in viscosity, particularly under cold storage condition. This increase in viscosity, especially under low temperature, can be attributed to the water evaporation and strengthening of the emulsion. And watermelon rain has natural polysaccharide, and it also can absorb the water and swelling to form a stable gel metric. This effect was even more pronounced in cold temperature, as the gel structure can be solidified. And compared to the commercial and watermelon rain has more stable viscosity. And moving forward to the spreadability and length that I have been combined both the spreadabilities. And for the watermelon rain and commercial sunscreen, it has showed degrees in spreadability over time, especially under cold temperature, just like the viscosity. However, the watermelon rain based sunscreen maintain a long-term spreadability compared to the commercial sunscreen, because it was reduced primarily because of the increase in viscosity, as I mentioned previously. And interestingly, the watermelon rain sunscreen, which contains natural emulsifier like beeswax in the ingredient, it remains semi-occlusive, which helped maintain the spreadability better than the commercial formulation. As we can see that the speed and length has a better improvement over the stability period. And lastly is for the greasiness. And the greasiness is also an important preference for the commercial sunscreen. And as I developed the watermelon rain sunscreen, it showed a low and stable greasiness with 0.20 to 0.22 centimeter throughout the stability period, which is just 0.02 centimeter variance. And the commercial sunscreen has showed more greasiness, likely due to its different composition of the ingredient like mineral oils, silicones in other formulas. So watermelon rain is more to aqueous and fibrous nature, like contributed to the low greasiness and offering a non-occlusive and breathable product. And this aligns with the consumer preference as well to promote lightweight, non-greasy products that allow skin to breathe while stay hydrated. And as according to the National Institute of Health, plant-based sunscreen are more likely to be less greasy because of their occlusive oils, absence of the occlusive oils. And this is why most of the consumers, they prefer less greasy sunscreens. And next is the comparison table, and as we can see that the physical chemical properties between the watermelon ring based sunscreen and the commercial sunscreen, as we can see that watermelon ring has outperformed the commercial sunscreen in several key parameters like the greasiness, spreadability, and also the pH. It was more stable, and the viscosity as well. It has a gradual consistent increase, and for the commercial it was more variation in the cool, and also for the spreadability. And yeah, so to conclude that the watermelon green sunscreen has achieved the objective by showing excellent physical chemical and stability under both conditions, even though there is variation, but it is not greater, and it has achieved the product specification, making it reliable for the sunscreen formulation as well. It exhibited better consistency than the commercial sunscreen, particularly in terms of greasiness and spreadability. And watermelon green proven to be the sustainable and effective ingredient for sunscreen formulation, aligning with modern sunscreen trends and circular economy goals. So for the future recommendation of this study, further study should conduct more stability testing, maybe for long term, like maybe 3 months. And in vivo SPF and safety validation should be conducted to ensure that the sunscreen is stable and suitable for all skin types. And consumer sensory also should be assessed for the market potential of the watermelon ring based sunscreen. And these are the acknowledgements, and I would like to thank Ministry of Education Malaysia for the FRGS scheme, and also Universiti Malaysia Kelantan for UMK Rising Star Grant and UMK Matching Grant. And these are some of the references supported this study, and special thanks to all the authors and researchers who committed to the agro waste utilization and sustainable cosmetic. And yeah, thank you.
Okay, thank you so much, Ms. Jiwashri.
Okay.
Okay, we have one question here in the chat box. The question is, what is the effect of varying concentrations of watermelon ring extract on the SPF value, pH stability, and rheological properties of a natural sunscreen formulation stored at different temperatures?
Okay, so these are the final composition I have presented in this today's conference is the after optimization. So before the optimization, there was a variance, higher radius, like sorry, higher ratio of watermelon green extract has been shown higher SPF as well, but it can be like in terms of the pH, if the pH is higher than 7, it can be not suitable for certain types of skin types. So combining of all the ingredients, it has to be stable in terms of the pH, viscosity, to ensure the final sunscreen compatibility of the skin. So some like a watermelon green extract, and it also the formulation has titanium dioxide. So combining both, it may promote like a more thickened version of sunscreen, which is not suitable for like oily skin types. So after the optimization, I have ensured that all the ingredients has to be intact to achieve the final physical chemical property.
Okay, thank you so much, Jiwashri. We are 5 minutes behind schedule now, so we cannot take any other questions. Okay, thank you so much for a very insightful presentation. We move to our next presenter. Our next presenter is Dr. Chang Siu-Wan with the presentation title of Real-Time Automated Tomato Ripeness Grading for Precision Farming Using Optimized YOLO 11 with adaptive features extraction. Dr. Chang, are you here?
Okay, I'm here.
Okay, Dr. Chang, you have 15 minutes for presentation. So the floor is yours. Okay, go ahead.
Okay. Hello everyone. My name is Zhang Qiuwen. I come from China. And
Okay,
now
Dr. Chang, sorry for interruption. Can you set your presentation slide to presentation mode?
more. It,
Can you change your presentation slide to presentation mode?
it's
Okay,
okay.
okay, never mind. Just go ahead. No, we can read it, no problem. Go ahead.
Good.
Yeah, you may proceed now. No problem.
It's okay.
Yeah. Go ahead.
I come from Faculty of Data Science and Computing, University Malaysia, Kelantan, and I'm very delighted to present my last work. Our topic is real-time automated tomato ripeness grading for precision farming use automated YOLO with adaptive feature extraction. With the continuous development of artificial intelligence, an increasing number of deep learning technology have been introduced into agriculture production to help farmers improve efficiency, reduce labor intensity, and increase income. Tomatoes are an important economic crop widely cultivated around the world.
Dr.
Characterized.
Chang, sorry for interruption again. Your slide is not moving.
Oh, why?
Okay, now I guess you should move. Yeah.
No moving.
Okay,
Why?
now it's okay.
No, it's moving.
Yeah, now it's okay.
Okay. I don't know why. And reduce the labor intense and increase income. Tomatoes are very important economic crop, widely cultivated around the world, characterized by high yield and short production cycles, with extensive planting areas globally. Therefore, introducing information technology into the tomato cultivation process and monitoring tomato ripeness through the technical means can efficiently enhance production effectiveness. Now it's another slide. From sowing to harvesting, the fruit exhibits various changes characteristics, such as the color changes from green to multicolored, the hardness from firm to soft, the taste from tart to sweet, and the smell from the imperceptible to fragrant. These characteristics can be extracted and qualified using different collection devices. Aware of devices are used to collect the aforementioned characters to analyze ripeness, such as the flowmeter sensors, spectrometers, electron noise, colorimeters, color image sensors, and so on. Now, the current trend trends of AI technology, scientists can begin to explore machine learning methods for detecting fruit material. Traditionally, scientists measure extracted fruit characteristics using computer vision method, then classifies the CV features using machine learning based on the features such as the color, shape, size, and the texture of the fruit. It starts with using computer vision for perceiving a feature extraction, then training the class features for classification. However, most involved class features are not robust enough for the all types of fruit, leading to higher misclassification rates. The material detection method based on the deep learning is becoming increasingly important and a key link in improving the efficiency of smart agriculture. The current fruit detection and recognition methods based on the deep learning for automatic harvesting can be classified into two categories. First, single-stage fruit detection and recognition methods such as YOLO and SD based on regulations. Two-stage fraud detection and recognition methods such as AlexNet, VGGNet, ResNet, FastR, CNN, FCN, SigNet, and MaskRCN based on the candidate regions. Then we collect the total of 1,463 tomato images from China for tomato detection and instant significant task. We use training data about 1,023 tomato images and valid maybe 293 tomato images, and the detection date about 147 tomato images used this training.
Dr. Chang, sorry, interruption again. It seems like you are still at the same slide. Maybe you have to move. Okay.
I already a lot of slides.
Yeah.
Maybe this already finished. Sorry, I don't know why my slide can't move it.
Yeah, no problem. Go ahead.
Okay. Okay. We adopted the Chinese commercial standard GT 1193 standard and condensed it into the 5 practical classes shown on the right. The table not only lists color ratios but also gives the actionable advice. Can it be harvested? How long can be stored, and how far it can be shipped? Is deployed system. Farmers get instant color code instruction. So we changed our model. Maybe I need. Sorry. First, we replaced our standard 3x3 convolution with the DESCON dynamic shape convolution, like the STX bond. This convolution adapts its receptive field to the actual fruit contour, catching counter boundaries under the and lifting map by 1.1% with the almost zero extra launcher. Then second, we planned an extra detection height at 160 times 160 resolution, dedicated to target smaller than 8 times 8 pellets, together with the weighted feature fusion. This flows even a cherry tomato has hidden behind a life to be located and grade correctly. Our industrial test site, our optimized model research 91.7% while outperforming the organized Universiti by the 2.4 points and faster ASEAN by the 12.8 points. Class-wise, the average miss rate drops to 4.3% and FASO positivities to 2.7%. So our conclusion is deep learning based on tomato material detection measures represent a significant development trend in smart agriculture for accurate, faster, and robust detection and classification methods. With the development of smart agriculture, further focus should be on ensuring detection accuracy while making the network models more lightweight, encouraging the models operating space to achieve real-time detection, designing the network architectures that can be quickly adapted to new conditions and make the model more general. This is our acknowledgement is from China and UMK. That's all. Thank you. Thank you for your listening.
Okay, thank you so much, Dr. Chang. Dr. Chang, we have one question in the chat box. I'm not sure you can read or not. Let me read it for you here. Okay, the question is, could this model be extended or transferred to detect ripeness of other fruits with different shapes or colors, such as strawberries, apples, pears, and what adaptation or modification would be required? You get the question, or you want me to repeat it again?
I think I need again.
Okay, the question asking, can you use the same model to detect other fruits that have different shapes or colors? So, and to do that, do we need to do some kind of adaptation or modification?
Oh no, from now on, we only use this model to detect the cherry tomato. If we want to use the other fruits, I think we need to change our model also. Yeah.
Okay. You see, you mean it's possible to use a model, but we need some modification, right?
Yeah, because different model have a different advantage. So our improvement model is fit for only fit for the cherry tomato.
Okay. So the current model is only for the current model is only for the cherry tomato.
Yeah.
Okay, I get you. Thank you. We can take another question. Okay, since we don't have any other question, thank you so much, Dr. Chang, for your good presentation. Okay.
Thank you.
Okay, so this is our last presentation for this session. We're gonna have our lunch break. So before we do that, I need cooperation for all our participants to turn on your camera so that we can take a group photo. Okay, thank you, Dr. Cheng. And then other participant, please turn on your camera. Then we can take a group photo. Okay, wait a second. Dr. Wong is showing now. Okay, all right. Okay, can we change the view? Change the view, how to change the view? Sorry, try to figure out how to change the view. All right, okay. Good. Never mind, we take one. Okay, guys, smiles. Okay, all right. Then we move to another page. Okay, one more. Yeah, okay, 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 smile, one more. Okay, 1, 2, 3. Okay, so thank you so much, all the participants. Okay, we will stop for lunch break until 2:30. So the next session will start again at 2:30. Okay, see you guys back after this. Okay, thank you so much. Have a nice day.